right, so yesterday we started looking at the introduction to quadratics. Today we're going to talk about characteristics. All right, so let's start with some notes. Parabola is the U-shaped graph of a quadratic function. The domain, just like on linear, is the set of x values on a relation, and the range is the set of y values. So remember, domain, range, x and y. Again, the axis of symmetry is an imaginary vertical line that divides the graph of a function into mirror images. Tells you where it's symmetric. The vertex is the point on the parabola that lies on the axis of symmetry. It is either the highest or lowest point on the parabola, depending which way your parabola opens. The x-intercept is the point or points at which the parabola crosses the x-axis. And similarly, the y-intercept is the point or points at which the parabola crosses the y-axis. A zero is a value wherever y equals 0. It's the x value on an x-intercept. It's also called roots, x-intercepts, or solutions. Extrema is talking about the max or the min. So the extreme on your graphs, the extreme highest point would be your maximum. So that's the highest y value. And then the minimum would be the extremely lowest point, or the lowest y value. Intervals of increase and decrease, we talked about a little bit during linear function. These get a little bit tricky on quadratics, so we'll look at some examples of this. But your interval of increase is the interval of x values that shows the graph moving upward from left to right. All right, and then decreasing would be your interval also of x values, because anytime you talk about intervals, it's from left to right that show the graph moving downward from left to right. Always go left to right when you're looking for intervals. And behavior we talked about with linear functions also. This is where do your arrows on the ends of your graph point to. So here, the behavior of the graph of f of x as x approaches infinity and negative infinity. And we'll look at some examples of that also. We also talked a little bit about interval notation. So when you write the beginning and ending numbers of an interval, you use a square bracket that look like this. When you want to include the end values, or you use round bracket or parentheses when you don't want to include the end values. So a little bit of review mixed in. All right, let's look at an example here. All right, so starting with domain and range. Domain, remember, is your x values and range is your y values. So as I look at my x-axis, I'm going from negative infinity on x to positive infinity on x. This graph continues all the way to the left and all the way to the right. So the domain then, how far to the left does it go? It goes all the way to negative infinity. And you can't include that, so you always put parentheses with the infinities. And how far to the right does it go? It continues all the way to positive infinity. And then the other way to write from negative infinity to positive infinity is all real numbers. A little simple. Now range is talking about the y value. So on your y-axis, the lowest would be negative infinity and the highest would be positive infinity. This graph does not go down to negative infinity. The lowest it goes is right here. Okay, so when you do domain and range, you always want to go least to greatest. The lowest point it goes to is -1, including -1. And the highest it goes to, it continues up and up and up to positive infinity. So that's how you would write that. The other way you might see it is y values that are greater than or equal to -1. So you can see it either way. All right, the vertex is this point right here where it changes direction, and we name that as a coordinate pair. So that would be -2, -1. And then your vertex tells you a lot of information. The first number, the x, tells you your axis of symmetry. So axis of symmetry is x equals -2. That's that invisible line that goes right through your vertex. The other number in your vertex should match one of the numbers in your range, either the highest or the lowest number. All right, your extrema is talking about the max or min. So looking at your graph, does this parabola have a highest point or a lowest point? Well, this one has a lowest point, so it has a min, and the lowest point is y equals -1. Also comes from your vertex. So you see your vertex gives you a lot of information. All right, x-intercepts, also called roots or zeros, all of those mean the same thing, are these points right here where it crosses. Okay, so a couple ways you could write this. You can write it as x equals -3, x equals -1, or you can write it as ordered pairs. So that would be -1, 0, -3, 0. Okay, either way. Same with y-intercept. So y-intercept is where does it cross on your y-axis? Well, it crosses right here, and that's y equals 3, or the other way to write it would be 0, 3. All right, the increasing and decreasing is the part that gets a little more complicated. All right, so increasing and decreasing, we're talking about intervals. And the best way to do this is to look at your graph, starting here, and move this direction. Okay, so always go left to right. As I go left to right, I'm going to follow it with my pencil. So I'm on my graph and I'm going left to right. My graph is going down, right? It's decreasing. So starting at my left point and all the way up until here, my graph is decreasing. And then it changes direction at my vertex. And now here on this side, it's going up. So from here over, it's increasing. Now we just have to figure out how to say that. All right. So this is always from -infinity all the way to positive infinity. We just got to figure out when it changes direction. Okay. And it's going to change at your vertex, which if we're going left to right, we're talking about on our x-axis. So at -2. Okay. This should match your vertex. All right. It's decreasing from -infinity to -2. So we're going to write that here. -infinity to -2. Up to -2, not including -infinity. It's increasing on this side from -2 to positive infinity. So I'm going to write that there. All right. Your end behavior is talking about the arrows on the ends of your parabola. okay? On a parabola, on a quadratic, your arrows will always be pointing in the same direction. Right? Either they're both pointing up to infinity or they're both pointing down to negative infinity, depending on what your graph looks like. So let's read this. As x approaches infinity, so as we go towards infinity on x, what is y doing? Y approaches, as we go this way, your graph is going up to positive infinity. As x approaches negative infinity, so as x goes towards the negative infinity side, what's our graph doing? As we go this way, our graph is still going up to positive infinity. On a quadratic, these will always match. All right, let's do another example. All right, so on the back, let's look at this first one on top. Domain, again, is your x, range is your y. So how far on the x-axis does our graph go? Now remember, these have arrows on the edges of them. This continues to the left, this continues to the right. So how far to the left does it go on x? It goes to negative infinity. How far to the right? Positive infinity. So from negative infinity to positive infinity, or all real numbers. The range is how low to how high. So what's the lowest point that this goes to? The lowest is -4. The highest is, it goes up to positive infinity. Other way you could write that is y's are greater than or equal to -4. The vertex is right here. That point is 1, -4. Again, we want to make sure this matches our range, which it does. And then this number is going to match our axis of symmetry, x equals 1. Extrema. This has a minimum. So it has a min at y equals, what's our lowest point of y? -4. X-intercepts. This has two x-intercepts, right here and right here. So the two different ways you can write it, x equals -1, x equals 3, or -1, 0, 3, 0. Y-intercept, where does it cross y? Right here. And that's y equals -3 or 0, -3. We can skip ahead to end behavior. So as our graph goes to the right, it's going up to positive infinity. As we go to the left, our graph is also going up to positive infinity. And we save the harder ones for last. So increase, decrease. All right, so starting on this side, up till my vertex, because that's where it's going to change. So from here to here, what's my graph doing? All right, well, from here to here, it's going down. So this is where it's decreasing. And then from here to here, it's going up. So it's increasing. All right, let's figure out how to write that. So it's from negative infinity to positive infinity, and it changes direction at our vertex, at x on our vertex. X on our vertex is 1. Okay, so decrease from negative infinity to 1. Increase from 1 to positive infinity. There you go. Let's do one more, one of these that's one of the frowny face parabolas, and look at the increase and decrease here. Okay, so starting here, and then here's our vertex. Okay, our vertex is -1, 4. We can go ahead and write that. So from here to here, something's happening, and then from here to here, something else. So this one, starting on this side, it's going up first. So it's increasing on this side, and then after the vertex, it decreases. All right, so the numbers stay the same, negative infinity, positive infinity, and then your vertex changes at -1. Now, when you write it over here, increase is going to be from negative infinity to -1, and decrease is from -1 to positive infinity. Sounds a little bit backwards, but that's how you would do it. And then the end behavior here, see how both of your arrows are pointing down? So as x approaches infinity, means this side, what's your graph doing? It's going down to negative infinity. As x approaches negative infinity, what's your graph doing? It's going down to negative infinity. See how these match? They're always going to match on a quadratic. See if you can finish this one and this next example.